Hi friends, welcome to our channel. So in this video, we're going to look at problem 2483, minimum penalty for a shop. Again, this problem can be addressed by partial sums. Let's quickly look at the problem statement. So basically, we have a yn string, right? So basically, the s character is either y means open or n means close. So if the shop closes at hour G, right, then the penalty is calculated as before. For every hour when the shop is open and no customer comes, so the penalty is increased by 1. Or if the hour the shop is closed and the customers come, then the penalty increases also by 1. So we want to find the earliest hour at which the shop must be closed to incur a minimum penalty. So this explains that if the shop closes at G's hour, then it means the shop is closed at the hour G and afterwards, right? So with that said, let's quickly look at the constraints. So this determines the problem size. So the length can be as long as 10 to the power 5, and the string consists of characters y and n only. So with that said, actually we can analyze this problem and do the coding. So here we can address this problem by partial sums. So basically, according to the computation for the penalty or the definition of penalty, so we let's assume that we close the shop at hour G. Then what we want to how to compute the penalty? Basically, we need to count the number of n before close hour and the number y on and after close hour, right? So this sum will be the penalty. Then we just need to minimize this, right? Minimize this around possible indices. So we can consider index 0, 1, 2, right? So n minus 1. So here n is the length of this string, but also we can consider n, right? Because we can make after the index, but we don't need to consider larger close hours. So like n plus 1 and n plus 2 and so on, because for these close hours we know the penalty is for sure no less than the penalty at hour n, right? So this is actually an important point to notice for completeness. With that said, let's quickly look at coding. So here I'm not going to use an ON space solution because this logic is rather straightforward. So we just directly give the O1 space cost solution. So here first I'm going to initialize a result. So 0 means index. Let's first assume we close at index 0 or hour 0. So what's the number of ends, right, before the close hour? Because at the index 0 nothing, so ends is 0. So on and afterwards are all the possible y's. Let's get the y's, right? It will be a count y. So notice that here I changed this name to be a just for convenience. So then in this case, the penalty will be n's plus y's, right? So then we can iterate. So here for y, so let's write g in order to comply with this notation. So for g in range 1, so here I'm going to write length n a plus 1, right? We consider up to n, the length, right? So, but we don't need to consider further close hours. So in this case, what do we want to check? So here we want to compute the penalty if closed at hour G. So if we close at hour G, right? So then we want to consider the number of ends before this one. So if a and j minus 1 equals n, right, then n is incremented by 1. So otherwise, so if this character is a y, so then actually the y's on and off j will be decremented by 1. So we are going to decrement this by 1. Then we are going to get this penalty. The penalty will be ns plus y's, right? N's plus y's. If this is less than the penalty, then we are going to set the penalty to be n's plus y's. And then we set the result to be the current close hour, j, right? So notice that if we have equality, we don't update the result because we want to return the earliest hour at which the shop will be closed, right? So that's basically about it for the main logic. So you can do the return now. Let's quickly do a check. Yeah, it passes all the test cases. Now let's look at the generic case. Yeah, it passes all the cases. So with that said, I guess that's basically about it for the coding part. But if you like, you can also, print out all the penalties. Let's see. So let's see j. This is close hour. Let's see the penalty. The penalty at this hour will be n's plus y's, right? Let's see. Yeah, this is for the first example, right? And j equals 0, we know the penalty is 3 because we have 3 y's. Then j at 1, 2, 3, we know the penalty is if you close at hour 2 is 1. And also if you close at hour 4 is also 1. But we need to return the minimum or earliest hour. So we are going to return 2 for this example. So with that said, I guess that's basically a walkthrough for example 1. So actually for this problem, the logic is rather straightforward. But you need to notice that in some complex situations, so the partial sum method or partial sum trick can be very effective. With that said, I guess that's about it for the current video. Thank you for watching.